Hey y'all, Jason here. Welcome to the first edition of Sweatpants Science. Now, you're going to have to take my word for it. I am wearing sweatpants. Today is a very impromptu video. In fact, I got really excited about something I saw and just had to shoot the video. It's not high tech, but it's going to be a lot of fun. So just hang in there and you're going to see it. I hope it's very enlightening for you. Horrible pun because it's a segue into the topic, which is light and how light travels through different mediums. And we're going to look at what the behavior of light as it introduces to the medium. These are the blue light blocking glasses. My wife got these in the mail today. They intrigued me because when she pulled them out of the package out in the sunlight, I noticed that they immediately became kind of a blue hue, the lens did at least, and then at the edge of the lenses seemed to illuminate a little bit blue. I also noticed in the box that it came with a card and a light. The card itself has a little strip on there that is sensitive to UV light. And this little light that came with it, part of that kit, that UV light, we can illuminate the card, and you notice that it turns pink where I shine the light. I thought, oh, well, that's cute. But that's all it is. It's not good enough. Because we got to go extreme, right? This is extreme. This is a UV laser. It's supposed to be purple, but it emits in the UV and the purple range. And you can see, there you go, that it turned blue. Now, what is this card used for? Well, this card is to kind of help confirm that you've made a good purchase, make you feel good about your glasses that you just spent, I guess, 10 bucks on. And you slide it in behind the lens and you take your dinky little UV light. In my case, you take the big UV light and you can shine it on the lens and then on the card itself. And what you should see is that the card that was under the lens was protected from that pretty invasive UV light. And I'll show you, I will run it all the way across to show you that it does react. We're outside, and I wanted to show you the UV strip when it's exposed to UV light on a cloudy day. Here it is. It's pretty overcast. It's not the prettiest looking of days, but here we go. We're exposing part of this UV tester strip or UV sensitive strip to the sunlight. Even though the light is diffused through the clouds, enough of it is actually coming down and hitting UV strip. And as you see, it's turning purple or violet. And there you have it. So let's run back inside. The lenses do as they say they're supposed to do. Now, what are the purpose of the glasses? Well, they're advertised as lowering the amount of UV and harmful blue lights can lead to all sorts of problems like headaches, migraines, sleeplessness, restlessness, and potentially prevent harmful degeneration of the retina, just due to age or macular degeneration. I did find that these lenses were pretty cool, and they did work regarding taking out the light. And in fact, you can actually shine through and you can't really, there's a little bit of transmission, but not a lot. But what I did notice when shining the light on the lens, you see, man, it turns super blue, and the edges, if you look towards the edges of the glasses, illuminate really bright. And this kind of took me back to some of my physics courses in how we discussed what the light does. When it enters the medium, if it enters, because it can reflect, it can either transmit through the medium or it can absorb into the medium. Now, reflection is pretty much the fundamentals of our eyesight. That's the way we perceive the world. That's reflected light. The medium can absorb some of those wavelengths, and that's the transfer of light energy into heat energy. Remember, conservation of energy states that we can't create it, we can't destroy it, we can only transfer it from one form to another, or convert it from one form to another. I'm trying to figure out what's going on with these glasses. Is it reflecting, transmitting, or is it absorbing the light, that UV light? Why is the lens illuminating around the edges that's super blue, and why is the lens itself turning milky? So this is telling me that it's potentially absorbing some of the light, but it's also taking that light and refracting it. Whoa, time out, wait a second. Reflection, absorption, and transmission. What's this refraction bit? Well, refraction is actually when the light enters that medium, it will change speeds. When it changes speeds, it bends the light. We typically see this when we're looking at prisms. And in the case of prisms, it separates the light. So it looks like it might actually refract some of that light, and then it bounces between the inner and outer layers until it reaches the edge and then emits out of the edge, and that's why we get a bright edge. Well, I want to kind of look at the absorption part of this to determine if it really does absorb any of that blue light. So we'll get to that in just a second. But what I wanted to show you in a demonstration was what transmission and what absorption look like when you're dealing with light traveling through a medium. So now what we have here are two liquids. This happens to be water with some flavoring that you get from the store mixed in. And then this, one of my favorite drinks, it's rum. And I wanted to kind of show you what transmission and absorption look like. When we take a green laser, notice it's green, there we go, it's pretty bright, and we're actually going to shine it down through the rum. And there you have it. And make sure I get adjusted. There we go. It's a nice straight laser. It's being transmitted right through. In fact, you can see it hit my hand on the other side. Now that's the green wavelength. Here's our UV light. As you see, it shows up bluish on the screen when it hits the desk. But look at this. Look at how the light travels in, and it seems to die off a little bit as it goes through the fluid. It's definitely not traveling through like that green laser did. In fact, there you go. There's a side by side. So now, what's going to happen when we shine the green light through the water with flavoring? Well, look at that. It's not like the alcohol, where we shine the green light through the alcohol, went straight through. In fact, this light is being absorbed in the water. And if you look at my hand, I'll scoot it over. You don't see any appearance of the light on the other side. So it's being absorbed into the water. So now let's try it with the UV laser. And look what happens. You can see a little bit right there on my finger. But you see, some of it gets absorbed and some of it actually transmits. So now here we have two different fluids and they're acting opposite. So if you ever go to the beach and you don't have sunscreen with you, just rub rum all over you, I guess. Yeah, who knows? Well, you'd have to have a lot of rum. That could be arranged. That is absorption and transmission within a fluid, and as you see, different wavelengths act differently in the different fluids. So let's get back to the glasses. Here we are with the glasses. We're hypothesizing that they absorb some of this light that's being transmitted through. When we absorb that light, we're transforming it from a light energy to heat energy. That's where this comes into play. This is a temperature gun. And if I'm correct, if there is absorption occurring within the lens, we should be heating this lens just a little bit. So there should be a temperature variation between the two lenses. This will be our control and this will be our test. Our control will be room temperature. Our control is reading at about 78 degrees. Now let's see what happens when we put the temperature gun onto the lens here. There you go, look at that. We're at 85 degrees already. 86. So we get 86 degrees on one side, and then we get 78 on the other. So yes, there is some conversion of light energy into heat energy as we're transmitting that light through the material. And yes, it does appear that some of that light is being bounced around, so there is some refraction that's occurring and illuminating the edges. Now, I did want to give you a bonus. Before you go running out, buying a pair of these glasses just because they block the blue light and you think you want them for your computer monitor, your TV, your cell phone, and all that jazz, I did want to bring up one last observation. We know that the glasses work great as far as blocking blue light, but really, how much blue light is being emitted and where do we confront most of that blue light? Well, this is where maybe they didn't think their marketing ploy all the way through, because now I have a test strip that I can place right on my monitor. And I'll leave it there for just a second just to see if anything occurs. I even have blue lines running across my monitor. And there you go. Look at that. You're probably going to encounter more blue light, more harmful light when you go outside. Not to say don't buy these glasses, but they may be better served if you go for a walk.